Alright, so let us consider the limit of this function f of x as x approaches 2. Now we have seen from our previous class that the limit of a function, say f of x, as x approaches a value, say 2, exists if and only if the left hand limit is equal to the right hand limit. So that is lim of f of x as x approaches 2 from the left is equal to lim of f of x as x approaches 2 from the right. Alright, so let's come back to this place now. We can actually see from the graph, we can trace down the limit of this function as x approaches 2 from the left. Right, this is point 2 now. This is point 2. This is left of 2, while this is right of 2. So we can investigate the limit now. If we approach 2 from the left, getting closer to 2, but not at 2. Because at 2, this function might be undefined. So let me assume we get closer to 2, but not at 2. Now trace it to the function. You can see that the function actually converges to a point 3 if I move it down to this place on the y-axis. So you can see that this function converges at 3. Okay. Now, if I move it from this place, you can see, not exactly at 2, but getting closer to 2, we can see that this function converges at 1 if I trace it down to this place. That means that the limit, the left-hand limit of this function as x approaches 3, as x approaches 2 is actually 3, while the right-hand limit as x approaches 2 is 1. So in this case, the left-hand limit is not equal to the right-hand limit. So in this case now, we can actually claim that the function is discontinuous at 2. So if the function is discontinuous at 2, then the limit does not exist at 2. From this diagram, you can also see the discontinuity. That's a jump from 1 to 3. So the function, the limit of the function does not exist at 2. We can actually conclude that this limit does not exist at point 2.